Geometry 7.4 is where we are. Triangle proportionality theorem. Look at that picture over here. We have seen in the last section a picture similar to this where we saw a couple of parallel sides. Are we able to prove that the small triangle and the large triangle are similar to each other? Yeah. Since we have parallel sides, we know that these corresponding angles would be congruent to each other, an angle-angle similarity. And so once we knew those were similar to each other, we could figure out some proportional parts to them. Now, in the process of doing that, we had to use this whole side, AD, as one of the proportional parts. But we are going to find from this theorem that if I have a triangle where you have a line parallel to one side, then it divides up the sides into segments of proportional length. This and this, these have the same ratio as AB to BC. All those pieces are proportional to each other. That's what this theorem says. So, down here, in triangle PQR, if ST is parallel to RQ, which they have marked right over here, we are parallel. If PT is 7.5, TQ is 3, SR is 2.5. They want us to figure out what is the value of PS. I'm going to call it X. I could say X2 2.5 equals 7.5 to 3. Now, I heard somebody start to say something else that would also work, I think, if I heard it right. I could say X2 7.5 equals 2.5 to 3. That is also valid. Let's look at the cross products of this one on the left for a minute. X times 3, or 3x, would equal 2.5 times 7.5. 2.5 times 7.5. What would I get if I tried it over here? X times 3, or 3x, equals 7.5 times 2.5. Are those equivalent statements? Do I get the same thing? Yeah, get the same thing. Doesn't matter which of those two you would have chosen to set up. You're good. Divide this by 3. You got your calculators running? What is the value of x? 6.25. Easy enough. So once I learned that theorem, or that thing that is true, then, doing the work is pretty easy. I'm not going to do the second one down here. It's the same. Well, let me make sure. PS, SR, PT, yes, it's exactly the same kind of problem. So we saw one example like that. Converse of the triangle proportionality theorem. Do you remember what this word converse means when we're talking about theorems? It reverses the hypothesis and conclusion. It reverses the thing. If a line intersects two sides of a triangle and separates the sides into proportional corresponding segments. So instead of starting, they shouldn't have started with that little thing right there. If I start with the fact that, hey, these things are proportional. CD to DP is proportional with AE to EB, or we could have written it a different way. Then if they are proportional, my conclusion is, sure enough, those lines have to be parallel to each other. Just reversing it. So right down here, triangle DEF. So that is the big one. Triangle DEF. If EH is 3, and HF is 9, and DG is 1/3 the length of GF. So I need to figure out some way to label these things. Can you come up with some way I can label it? GF is equal to X is 1/3 X. That would work. Can you think of another way I could have labeled those two? I could have said, well, DG is X. And then what would I call GF? 3X. You got it. Either way will work for us. Let's use the original ones that I had. Now, what am I needing to do? I want to see if these things are parallel to each other. Question mark on that. Well, if they are parallel, it means we are proportional. So I'm going to see if they're proportional, and I'm going to start with the red ones. So what do I do if I end up with a fraction? Well, 1/3 x should correspond to what? 3. I can go that way. Equals x over 9. Well, I'm just going to try my cross products and see what happens. 1/3 x times 9. 1/3 x times 9. Will it equal 3 times x? Well, what's 1/3 times 9? 3. Does 3x equal 3x? Sounds good to me. So those things are proportional, so our conclusion would be yes, we must have parallel lines right up here because it divided it up proportionally. Let's try this second one. If DG is half the length of GF, so DG is half the length of GF. Label it for me or tell me how to label it. Sounds good to me. DG is half of GF. And EH is 6. HF is 10. Before I do any work, can you tell me if this is going to work or not? Why not? Yeah, here's the deal. X is half of 2x. Is 6 half of 10? No, it's not. I'll do the math right down here because we can't just say, no, it's not. We need to see how it works out. I'm going to say x to 2x, does it equal 6 to 10? I'm going to do some reducing. What is x over 2x reduced to? 1/2. The x's cancel out. They go into each other once. I have 1 over 2. Reduce 6 over 10 for me. 3 over 5. We're in trouble if it's 2 over 5. No, those things are not proportional, therefore those lines would not be parallel to each other. Okay, so there was the first theorem, and then the converse. Just turn it around. Mid-segments of triangles. We've talked about mid-segments of some things before. Mid-segments connect what? Can you figure it out? You can look at the diagram. The midpoints. Mid-segments connect midpoints. So R is a midpoint of AC. We have those two little marks showing they're congruent. P is the midpoint of AB. So if I connect those two, it's called a mid-segment. Q is the midpoint of CB. So if I connect, I've got another mid-segment. I have another mid-segment. So those happen to be the 3 mid-segments of triangle ABC. So mid-segments connect the midpoints. We are going to find some things, some facts that are true about mid-segments. A mid-segment of a triangle is parallel to one side. So if J and K are midpoints, then right here is a mid-segment, and that mid-segment is going to be parallel to the obvious side. I hope you understand it's going to be parallel to the side it doesn't intersect with. Can't be parallel to these two here. Must be parallel to the one that it doesn't intersect with. And its length is 1/2 the length of that third side, the side it's parallel to. So 2 facts. When I have mid-segments in triangles, they're parallel and they are half the length. So right up here in this figure, XY and XZ are mid-segments. XY is a mid-segment, and XZ is a mid-segment. So we know those things are midpoint. X, Y, and Z must be midpoints then. Find each measure, X to Z. They want to know, what is X to Z? You tell me how I'm going to get it. 13 divided by 2. This X to Z must be half the length of R to T down there. What's 13 divided by 2? S to T. S to T. How much? Must be 14. It must be 2 times segment. 7. Its mid-segment over here is 7, parallel to ST. Having a hard time talking, aren't I? So it is half the length. So if I double the mid-segment, it must be ST, which is 14. Measure of angle RYX. RYX, this angle right up here. How do you know it's 124? Yeah, we know that these lines must be parallel, and so 124 and this one over here are alternate interior angles, must be congruent. Man, this geometry stuff is easy. Find each measure. DE. So looking at this, the first thing you want to notice is D must be a midpoint. How do I know D is a midpoint? Bisects a segment. I've got two congruent parts right here. E is a midpoint, same reason. F is a midpoint, same reason. So I know I have all these midpoints, so I know I have mid-segments. I'll make one blue, one green. Those both must be mid-segments. So DE, 7.5. It's got to be parallel to this AC and half the 15, so it must be 7.5. DB, DB. How much? 9.2. How must it be 9.2? Well, you got it. A to B must be twice the 9.2, which would be 18.4. And DB and AD are congruent to each other, so it's back to half of the 18.4, which is our 9.2. Measure of angle FED. FED. So this angle right in here. How much? 82. Man, this easy geometry stuff. Those things are parallel lines here and here, so therefore we have alternate interior angles. Moving on. Proportional parts of parallel lines. Our third fact for today. This is a corollary of the last one. If I have 3 or more parallel lines, so AE, BF, CG, you could keep going. If you have 3 or more parallel lines, intersect 2 transversals. So we just randomly draw 2 other lines that are transversals over here. Then they cut off the transversals proportionally. So these parallel lines are cutting off little segments on the transversals. And what they are saying is all these little segments are proportional to each other. And we can keep going. It doesn't just have to be 3 parallel lines. 4, 5, 6, 7, 8, 9. All those things will be proportional to each other. So you can see a possible statement that they did. They did AB to BC equals EF over FG. Well, I could have gone left to right. I could have gone AB to EF and then BC to FG. But you cannot go diagonally. Don't say, oh, AB to FG. No, that doesn't work. I have to keep consistent horizontally or vertically when I do it, and then your proportion is going to be correct. So here's an example, and then we'll do one of our own. Megan is drawing a hallway in 1-point perspective. Maybe some art class you had before, you had to do perspective drawings. Do you remember doing perspective? Oh, some of you know, some of you yes. You've picked this vanishing point up there, and then you draw your lines that come out, radiate from that point, and that gives you the perspective of depth. See, doesn't that look like a long, long hallway? Maybe a little over-exaggerated, but a long hallway. She uses guidelines shown to draw 2 windows on the left wall. So see, she made her perspective lines going to that vanishing point out there. And it says if segment AD, BC, WZ, XY are all parallel to each other, then it gives the measurements of it, and they want us to figure out what is our WX, one of those points out there. Well, these are all proportional. AB, DC, WY, XZ, they set up a proportion, and they figured out a nice fraction. It didn't go in evenly. So let's try one of our own. You're a realtor. Frontage is the measurement of a property's boundary that runs along the side of a particular feature, such as a street, a lake, an ocean, a river, a mall parking lot, whatever it is. Frontage is just one side. Find the ocean frontage for lot A. Ocean frontage. Because you are going to advertise, when you put your newspaper advertisement, that it has 632 feet of oceanfront property, or whatever it is. Find the oceanfront for lot A to the nearest tenth of a yard, so I guess they're going to let us round it out just a little bit. So you start setting up a proportion for me. Somebody out there has an idea. 42 over what? Okay, if I go 42 over 58, that will work. We're going bottom to top on this side. Therefore, I need to finish it with 60 over x. We'll call this x right up here. Good enough. So 42 times x must equal my 58 times my 60. So if I want to get rid of that 42, we'll divide by our 42 and to the nearest tenth. How much? 82.9? 82.9. This was all measured in yards, right? Yards. Now, if they start mixing feet and yards, make sure you get them in the same unit first before you start doing things like that. Let's set up this one. What could I set up in this scenario? Jesse, you have it? Oh, good morning. 7x minus 2 over 4x plus 3. If I decide to set it up that way, I would finish it. 8 to 8. Huh. I could reduce this if I wanted to. What does that reduce to? 1 over 1. Now, I'm not going to say just to 1 because I want a proportion. It does reduce to 1. 1 to 1. So 7x minus 2 times 1, well, that's pretty easy math, must equal 4x plus 3 times 1. That's also pretty easy math. Subtract 4x, how many x's? 3x. Add your 2. 5. X equals 5/3. Good answer. Who said that? X is 5/3. So this one right up here, how could I do part B? It is equal. And I don't want to use my 2x plus 1 and 3x minus 5 again. 1 to 1. That's exactly what I want to do. Remember back here, it happened to be 8 and 8. Maybe it's 9 and 9. Maybe it's 20 and 20. I don't know what they are, but I do know when I reduce them, it's 1 to 1. So just like last time, 2x plus 1, since times 1 doesn't change it, equals 3x minus 5. So subtract my 2x, that just leaves 1. Add my 5, 6. That wasn't very hard. X must be 6. Got your compass? Get your compass out. We are going to learn how to trisect a segment. I think your teacher last time said, remember to bring your compass to class. It's all right. We'll give you some points for those who remembered it here in just a little bit. On your paper, right at the top, right before your homework, draw a segment with a straight edge. Make that segment fairly long. Don't want to make it too small. Pick your 2 favorite letters. Maybe they're A and B. Maybe they're P and Q. Maybe they're J and G. I don't know. Maybe we won't keep admitting what our 2 favorite letters are. Might give away secrets. A, B. I don't know. We want to trisect. What do you think that means? Well, the idea, bisect it 3 times. I think you're on the right idea, but what does bisect mean? 2 equal parts. So trisect means 3 equal parts. We want to trisect this segment. We want to divide it into 3 equal parts. So first thing again, just get a segment. Use your straight edge, get a segment. Needs to be some nice length out there. And the next thing to do is use your straight edge again and make another segment from A that's coming down at some angle. Maybe it looks like it's about 50 degrees. Don't measure it. Just come down at some angle. And make it fairly long as well. Now you use your compass. And you make your compass some convenient length. See if I can, there we go. Make your compass some convenient length that is not too small, but small enough that you can start at point A and, leaving it this size, mark off 3 congruent segments on this angled line that you drew. So you're choosing just whatever you want. Whatever size it is, make it large enough, because when we do constructions, we need big enough things to draw with our compass in. You just mark off 3 congruent segments down here. Now here is the theory behind this. Oh, you can do one more thing before I tell you the theory. Now take your straight edge, and from the last mark, draw a segment from that last mark right to the end of that AB, or whatever you call it, we're going to trisect. So wherever that last mark is, doesn't matter what size you chose. Now here's the theory. Don't draw these next 2 lines because I'm going to erase them in a minute. If I made parallel lines like this, I mean, use your imagination, but if I made parallel lines, then what has to be true? They're all proportional. And if I made my original ones all congruent to each other, which is what we just did, then these up here must all be congruent to each other. And I just trisected that segment. So that's what we are going to be working on doing, is creating some parallel lines. Now, in order to create parallel lines, let me go ahead and throw one of those dash things back up again for just a moment. In order to create parallel lines, I can copy this angle right up there, because those are corresponding angles, and if those are congruent to each other, then I know I must have parallel lines. So that's the theory we're going to work off of to get our parallel lines. So how do I copy angles? Maybe you remember how you copy angles. Take your compass, and again, open it to a size that's not too small. I'm going to put my point of the compass right where it's going to be the vertex of one of the angles I'm trying to copy, and make an arc. Make sure your compass doesn't change sizes now. Now I'm going to move it up to what's going to be the vertex of where I want a new angle that's the same size. Make that arc again. And I'm going to do it one more time. Move it up. Whoops, I'm going to have to move everything. Left my B behind. There we go. Keep your compass again the same size. Move it up to the last one where you are going to have another vertex of an angle. And copy that arc again. Now you can change the size of your compass. But I have 3 arcs all with the same radius. And now all that is left is to measure how big that angle is. So I'm going to use my compass and measure that gap in the angle. How big is my angle? Looks like my angle is right about that size. Yeah, it looks pretty good. That's the size. So now I'm going to come up to this other arc and measure that same size. Oh, right there. That'd be the same size gap. Then I'm going to come up to my top one and I am going to measure the same size. That'd be the same size gap. So I'm actually through with my compass now. Now we're just back to our straight edge. Use your straight edge and go from that vertex right through that X. I should have a parallel line. And if I do it again, that vertex right through the X, I should have another parallel line. So with a minimal level of skill, which is about what I possess, should have created 3 nice parallel lines with a result that these segments that I cut off should all be congruent to each other. So for me, the moment of truth is going to be, well, let's measure it. Let's see. 4, that looks about right. 4 units is my first one. Woo, 4 units is my second one. 4 units is my third one. We just trisected that top segment. So this construction actually works to trisect, quadrisect, 4 congruent parts, 5 congruent parts, 6, 7, 8, 9, you got it. You can now do it with this construction. Let's go to the book. In a little bit, I'll check those of you with a compass so I can reward you for bringing your materials. But let's go to page 395. 495. Let's not go back to 3. 495. So right underneath your construction work, number 1. Copy that little diagram out there. Won't take you very long to do it. So I want you to be using diagrams on your paper, labeling them. We've done this many times. That's how you do good work. XM is 4. 4. XN is 6. 6. NZ 9. And find X2Y. So they want us to find that. Well, I'm going to call my missing little piece X right up there, but we're wanting to find that total length. What can I set up? X to 9, I could do that, equals 4 to 6. X times 6, or 6x, would equal 9 times 4. And then if I divided by 6 to isolate my X, how much? 6. Now that's not my solution. That's what X is. What's my answer? 10. Segment XY must be 10, that complete length. Number 2, using my same diagram, I'll just erase the values I had before. Start again. XN is 6. XM is 2. XY is 10. Clever. XY is 10. They want us to figure out what N2Z is. Well, what might be another necessary bit of information? Yeah, this has to be 8 up there since 2 and 8 are going to make 10. Okay, so we overcame that difficult hurdle. Now what? X over 6. Excellent. You picked another way. X over 6 equals 8 over 2. 2x would equal 6 times 8. I can now divide by 2. The value of x is 24. Now let's make sure we answer the question. N2Z, that is what they wanted us to figure out, was this thing right down there. So there's our answer. Number 3. Triangle ABC. So a little diagram again. If you have your straight edge handy, you can be as fast as I am drawing these. You just use your straight edge to whip out those nice lines. Oh, I didn't quite get mine oriented all together, so we'll fix that. Looks more like that, doesn't it? All right. BC is 15. B to C is 15. That's the whole length. BE is 6. 6, that little piece. DC 12. AD 8. Determine whether DE is parallel to AB. Their question is, are these parallel to each other? And then justify your answer. What do we need to check to see if they're parallel? Proportional segments. Now, I need a little piece down here. What's this bottom piece? That would have to be 9. So let's see if we are proportional. If I started with 8, how could I go? 8 to 6. That'll work. Question mark. What should it equal? 12 to 9. Make sure you pick the segment. Well, let's reduce these. 8 to 6. How does that reduce? 4 to 3. How about that 12 to 9? 4 to 3. It reduces the same. Check. And so my answer would be yes, they are parallel. And my reasoning, you can just say it in words. What did we just do? The segments were proportional. Number 4. Another diagram. Maybe I can make my picture look a little closer to theirs. I'll put my letters with it. J, M, K, P, L. JK is 15. JM 5. LK 13. PK 9. And again, JL parallel to MP. Well, we're missing some things. My 5 is a segment, so I'm happy with that. My 9's a segment. LP would have to be 4, and MK is what? 10. So checking whether we are proportional again is our deal. So let's say I started with the 5. 5 to 10 works for me, equals 4 to 9, or at least that's the question mark. What does 5 to 10 reduce to? 1/2. How about 4 to 9? Nope. Those would not be parallel. We do not have proportional sides. Number 5. JH is a mid-segment of triangle KLM. Find the value of X. Tell me how on number 5 we're going to get X. Half of 22. So our answer would be 11. Not much labeling we needed to do there. Sometimes we need to. 6. 2 times 5. 10. Like I say, this nice, easy geometry stuff. Number 7. What's that? What? I don't know. 7. Refer to the map at the right. 3rd Avenue, all right, we're looking at 3rd Avenue. There it is on the far left. And 5th Avenue are parallel, so the city planners did a good job drawing out the streets. If the distance from 3rd Avenue to City Mall, who would be interested in the City Mall? But anyway, and along State Street, so along the bottom there, is 3,201 feet. Oh, I need a diagram. We have 3rd Avenue, we have State Street down here, we have something else, and 5th Avenue. And they already tell us, what, 1056 and 1162? 1056, 1162. And then they described going from 3rd Avenue to City Mall along State Street was 3,201 feet. Somebody counted their steps when they went to the mall. Find the distance between 5th Avenue and City Mall along Union Street, and they say round to the nearest tenth. So here's what they're wanting to know. X. Well, we better find out this segment. 2145? Okay? So let's say I start with 1162. What can I do with that? Over 1056 equals X 2145. So 1056 times X must equal 1162 times 2145. What? Divide by my 1056 to isolate my X, round to the nearest tenth. Point 3. 2360.3 feet. Oh, too far to go to the mall. Guess we can't go. 8. Find X and Y, they are saying. All right, we have some parallel lines, so we know we've divided these things up proportionally. I want to start with Y. Can you tell me an equation on number 8 that would help us find Y? Okay, one way or the other. Those are congruent segments. So let's start there. We know that 3y is going to have to equal 1/2 y plus 20. I'm going to get my y's together. If I subtract 1/2 y, what do I have? 2.5 y equals 20. I want to change that 2.5 to an improper fraction. What would it be? 5 over 2y is 20. That way I can multiply by what to get rid of that 5 over 2? The reciprocal 2/5. And so y must be, how many times is 5 going to 20? 4 times 4 times 2 is 8. We just figured out what y was. That allows us to do some measurements now. So on our diagram, you don't have to draw this one out. It's pretty straightforward, I think, without them. But I want to figure out these lengths. Or do I need to figure out those lengths? Wow. Who drew that thing? That certainly, yeah, I'm guilty. That certainly doesn't look like what theirs is. But it's going to in a minute. Yeah. What do I know about these sides right over there? Since they're congruent or equal to each other, what's the ratio between these two? I'm 1 to 1. Whatever the length is, I don't need to know. I'm 1 to 1. So then I can take my, what is it, 20 minus 3x? 20 minus 3x to 1. 2x minus 5 to 1. Which is the same thing as just that they equal each other. So if I added 3x, 5x, added my 5, 25. X must have a value of 5. Number 9, we've got parallel lines, transversals, so we know these things must be proportional to each other. Boy, they did it again for us, didn't they? They have congruent things. So what do I know about 12 minus 3y? 16 minus 5y. I'm going to add 5y. How many y's? 2y. I am going to subtract 12. 4. Y equals 2. And what do I know about the right side then? They must be equal to each other, the same proportion. 1 to 1 must be 1 to 1. A quarter x plus 6, 1/4 x plus 6 must equal 2x minus 29. Well, if I subtracted a quarter x, how many would I have? 1 3/4 x. I'm going to add 29. 35. Let's change that 1 3/4 to what mixed number? 7/4 x. So I can multiply by 4/7 in order to eliminate it. How many times does 7 go into 35? 5. 5 times 4 is? 20. Your assignment from page 495. We have numbers 1 through 27, 35, 36, 40, and 41. Now, those with compasses, why don't you just